Welcome back to Larry Grate,
Thank
our
you.
best guest so far, and Terry Miller, our second best guest so far.
Yeah, I knew that was coming.
You walked right into it. You didn't even
I
have to
know.
set me up.
I didn't have to even walk. It just came to me.
Sometimes I wonder if being mean to you is a bad idea.
No, it's not.
No, it's a good idea.
Yeah.
Wow.
Thanks,
Larry.
Larry.
Larry trying to keep earning the first best guest accolades.
Larry climbs to the top rope and drops the elbow.
Well, I figured Terry and I go back far enough I can get away with that. See, I probably couldn't say that to you, Russ. So.
I feel like I have a thick skin on some things and then a surprisingly thin skin on things. And when I say surprising, I mean often I'm surprised by what I have a thin skin on.
Gotcha. Oh,
Terry, you have a bone to pick today.
I really don't.
That's what you say every time you have a bone to pick. You always say, "I have no axe to grind. I have no bone to pick." But you're trying to test out what me and Larry know.
I am. I'm just, since we're throwing around degradations
Insults
freely at the beginning of the show here, I'm going to go ahead and say Larry's going to know more.
Fair. Ow. That's totally fair. That's fair.
So, no offense.
Wait, what is the topic? Fish?
No,
I promise you know more about fish.
Birds?
See,
you know more about birds.
Sorry, little inside secret. Russ is secretly pursuing a PhD in zoology somehow secretively. He's not, but he should, because literally he knows everything about every species, things I've never even heard of. He's got information on.
I'm just an enthusiastic amateur, really. Terry, is there a formal test at the end of this?
There's not, but we're going to start with question 1. Larry, what is the best PLC on the market?
Oh my God. Oh, I'm screwed.
I'm screwed. I can't win this one no matter what I do. What's the best PLC on the market?
The ears in Milwaukee just sort of turned to the south. They want to hear this answer.
So see, I have to answer the question with a question. What problem am I trying to solve?
Yeah, I knew that was coming.
Batch manufacturing.
Ooh. So if you're talking about batch manufacturing from a process perspective, then I would have to probably give the nod towards, and there's going to be some people that are going to really disagree with me, but that's okay. Because of the flexibility and the ability to essentially go from a really simple solution to a very highly granular, highly complex solution, and all the variations that exist along that line, if you will, I would have to give the nod to Rockwell with Control Logics and FT Batch.
Mr.
Do I have
Waddell,
to answer this question?
You do. He's Googling, like, what is a PLC? Who makes PLCs?
I know better than that.
On the top of off the top of my head, I was trying to figure out how to completely dodge the question. I'll say this.
You can just say next.
I have never programmed a PLC.
Really?
I've never owned a PLC. I've never been responsible for the upkeep of a PLC. I therefore feel unarmed to give an opinion about what the best one is.
So,
Terry, do I get a pass on that, or are you going to hold my feet to the fire?
Well, I mean, I'm not going to hold your feet to the fire. Larry,
I mean, I can pick one anyway.
Yeah, just name a PLC. How about that?
it's the from yeah, that's them.
D-. Larry, here's question 2. Is a PLC the best control system for batch manufacturing?
Ooh. See, now that, again, I'm going to have to follow up with either a question or an it depends, because it really, for me at least, would depend on how that sits in the rest of the manufacturing process. If I've got a very process intensive application, and batch is a piece of that, meaning I've got a lot of continuous process, maybe some distillation columns or chemical manufacturing, things of that nature, then I'm going to lean more towards the DCS environment than a PLC or a PAC environment. And I know there's a number of vendors out there that want to try to blur those lines, and they've certainly done a good job of that in the last, let's call it 15 years. But there's still a difference, and I would still lean towards a DCS. Now, if you're going to ask me what DCS, we're in trouble.
I mean, it's the only one I know. It's Ovation or S7. There are two, right?
So
Or is S7 the
Ovation
PLC?
S7 is the
What's
PLC. So PCS7 is
gotcha?
the
DCS.
Siemens DCS manufacturer or DCS product. Um, so Ovation, very niche in power, right? Owns most of the power in North America. PCS7 wouldn't make my top five. And I probably make a lot of Siemens guys mad in what I just said. And my argument for that would be that it's kind of like, in my opinion, a little bit like Delta V, which is going to make some other people probably angry, in that it really wasn't built as a monolithic solution from the ground up. It's taken an HMI and trying to do what Rockwell's done with Plant PAX, only I will argue they maybe did it better in some regards, and make it look like it was a monolithic design from the ground up. Whereas folks like ABB and Foxborough or Schneider and some others have something that's a little more what I would consider to be really monolithic.
Russ?
I'm sorry, I forgot the question.
DCS. Best
Oh,
DCS.
what's the best solution? Is a PLC the best solution for batch manufacturing? Was that the question?
Yes.
Do I get extra credit for remembering the question when you didn't?
I remembered the question. I just stated one obscure part of the question first.
Fair.
And then was making my way to the remainder of it.
Well, I fall on a very different side from Larry here, because he specifically said, there are benefits to building out a more monolithic, aka a better integrated top to bottom solution, and the more integrated, the better. I've spent all of my career time basically, I would say, on a wing and a prayer that the monolithic solutions will fade out and an appropriate working, functioning microservices architecture will take over, as has happened in mainstream software. So what this means is if Larry's talking about monolithic, means I need to control, let's say, a power plant, and I've built a power plant specific control system. The opposite take, the microservices approach, would be I've built a motion control module, I've built a alerting module, I've built a temperature feedback module. Pick your set of things, and now I've laced those together in a way that is, the lacing may be specific to a power plant, but each of those modules can be slotted into any place under the sun, and that's the way that most consumer facing mainstream software and some business enterprise software has gone over the last 20 years. And I've kind of like hitched my wagon to the idea that that's going to happen in industrials as well, with mixed success, mixed results, and mixed progress through the industrial space.
So I have to go to the gentleman with the proverbial dirt under the fingernails here.
For the point?
Well, you've impressed me with your response, but I think
so far I've answered 0 out of 2 questions.
Yeah. Well, you just answered that one. Actually, you kind of answered it. Yeah.
I firmly did not answer. You said, what's the best control system for batch? And I didn't even name a control system.
No, but you kneecapped Larry's DCS explanation. So I'm coming back to Larry.
Oh, I'm glad this is competitive, by the way. And I'm glad I'm losing. It's more interesting that way.
I don't know that you're losing, because, to some extent, I would argue that far enough down the road, you're probably right. If you look at the Open DCS, or I'll think of the name in a moment, essentially, right? That's effectively what they're after. So Exxon said, I'm not going to replace my aging Honeywell infrastructure with a proprietary closed DCS system. I'm going to use an open solution, and actually leveraged a lot of what Lockheed Martin did on the F-35 from a user interface microservices perspective to build out an open DCS platform that you could then actually have different vendors, i.e., I won't name them just in case there's a problem with naming them, but different DCS manufacturers building different components, plug it together, and make a DCS system out of it. It's coming.
Okay, so you basically answered what I wanted. There's always the art of the possible in everything, AI especially, but there's the art of the possible, conceptual, this works in FANG, so it's going to work in all industry. There's that mindset. Then there's the way things really work in application with operators that have been doing it for 30 years, blah, blah, blah. So open source / modular approach to controlling power plants, cement plants, heavy industry. Yes, no. Seems like that's one of those things that conceptually sounds good, but in application will not happen.
So I'm going to put my cybersecurity hat on for a minute and tell you that I think you have to look at it from a risk-based approach perspective. I mean, if you set me in as the senior controls manager for a large oil and gas company, would I look at an open solution for controlling my refinery? Absolutely not. The risk associated with that not working the way I expect it to is just too high. There's not enough runway, if you will, under the aircraft to say that it's going to be a stable solution. However, if I was to use the cement industry as maybe the other end of that, right, where I don't have quite the same level of risk if things go south, I might consider it if I was looking at a much larger rollout of a technology refresh essentially across an organization. So I think somebody's got to be first. Somebody's got to be successful. You got to get some runtime under your belt, and I don't think I won't say ever. Would be a mistake. It'll be a long time before you see any kind of open safety instrumented system, I think, because of all the implications associated with that. But I think, to Russ's point, eventually you're going to see an open DCS platform do more than it ever has. Now,
Russ,
will it be in my career or not? I don't know.
I'm going to give a yes and. So everything Larry said, and also when we think about open source software, particularly if we're thinking, big examples, so Linux, the Linux desktop environments, open source stuff that you just use as a nerd, a regular nerd, not necessarily an industrial nerd. A lot of times this stuff has been packaged up and is kind of like ready to go. So if I'm using an open source alternative to Adobe Photoshop, I have the GIMP editor, and it basically looks like a cut rate version of Photoshop in a lot of ways. In business software and in enterprise software, for sure, and definitely in the industrial space in an increasing degree, where open source comes into projects is not, you wouldn't necessarily say, oh, here's the entire software package that's open source. Like, there may not be open source CAD software, but you could have somewhere down in the stack of dependencies, there are, very large open source libraries that are part of building the end solution. And so you hear this concept of the software bill of materials, which is basically like not made any progress whatsoever when you think about what controls the physical equipment. Okay, well, it's software. Well, what software is behind that software, and what's behind that and that and that and that and that as you go down the stack of which things need the other things. So open source libraries are making their way into industrial software now. And I think the most likely situation is something bad happens. It was because of an open source dependency far down the line. Some CTO who is somewhat removed from, wrenching on stuff says, we're not going to do open source anymore. And that's going to, put a damper on big forward facing open source projects. Now, the flip side of this is industrial companies are incredibly cost conscious for the most part. And there are a couple of exceptions, but mostly they're razor thin margins and they're always looking to save a buck. So if they have a choice between Terry's software that doesn't come with a software bill of materials and you don't know what's in there and it's cheaper, or Larry's software, which has a software bill of materials but costs 10 times as much, there are a lot of cases where they're going to go with Terry's cheap software and have no idea what open source libraries went into it. So I would say the question has many questions within the question.
Yeah. There's the conceptual angle. I want to leave that topic though, and I want to have for Larry this is like a segue question. We just talked about DCS and PLC, and so I'm thinking of like those graphs or those charts where it shows the evolution of man from like Neanderthal through today. What are our control architectures from PID loop controller? Maybe there's something even, even more rudimentary than that. What is the least complex to most complex control thing, device, and maybe a blurb of why you'd use one over the other?
Ooh, so you're looking for things that would still be used today, not necessarily things that we maybe stopped using 20 years ago. So I'm trying to understand the Neanderthal question, right? Am I going back to something that doesn't we wouldn't use anymore, or am I not going that far?
Yeah, let's go back. Let's go back to things that you might find in some, hole in rural Tennessee somewhere, but you know,
Yeah, so if you chase control back, right? We actually used to implement PID in the physical realm, right? We would use things like pneumatic bellows, and we'd use needle valves for air integrators, and we would adjust the relationship of input to output physically to get gain. We really didn't have a derivative term in those, but those, and in some cases they were literally all pneumatic, right? I mean, you literally had a level sensor on a tank, for example, that you ran a usually it wasn't 3 to 15 back then. It was, I guess, 10 to 30. I'm trying to remember what the air pressure range was. And you'd get a signal out of that proportional to the level as air pressure, run that into another device, essentially, that was all pneumatic, that would then, hit a control valve with a 10 to 30 signal going out to a control valve and adjusting the level control. So what we've done over the last, let's call it 50 years at this point, basically, is we've digitized all that, right? So now I've got a level transmitter sitting on the tank that's all digital. I hit it with a 420 milliamp signal, or maybe now it's PoE, and I'm coming back to a computer somewhere that's doing the PID all in math. And then I'm going back out to an actuator, essentially, at the end of the day, that might be a PoE device. It could be all electric, or it could actually still have a pneumatic component to it. And I'm producing a 3 to 15 PSI signal, essentially, to proportionally control a valve of some type. And so that's kind of the what's happened in that space over the last, I would argue, 50 years. I mean, I remember sitting in a paper mill 20 some years ago and finding a bunch of pneumatic level loops in the basement, and we were all kind of scratching our head and amazed that they'd been working since the machine was originally installed in the 60s, essentially, right, or early 70s. I'm not sure that answered your question, but that was where my head went as you kind of described those pictures. I mean, to me, that's what you see if you look at the control world. We've inserted different things in there, right? We've made it along the way. We had single loop digital controllers for PID. We, went to PLCs to some extent, DCS systems, and now you've got other things essentially getting in the middle. And maybe the most advanced, to take the other extreme of it, would be a multivariate solution. Right. So something where I'm using a multivariate control system that may or may not actually still use a PID loop underneath it. In most instances it does, but sometimes you're directly controlling an end actuator of some type using a multivariate matrix. And it's going to be interesting to see how AI impacts that over the next 5 to 10 years. And it's already impacted it some in terms of tuning, but it's going to impact it more, I think, in terms of eventually direct control, which scares the heck out of me personally as a controls engineer, but it is what it is.
So are you speaking specifically about model predictive control?
So that's an example of multivariate control. Yeah. That's in that situation, there's still some physics involved, which is kind of nice. And that's what I like to see. But there are certainly other solutions out there that are more decision matrices and things of that nature that even get away from anything that's physically model based.
Yeah. So that's the segue question. That's the controller. And you've, I think, by default, walked us into the topic that I want to go to now. And this is more competition. So open question, starting with Larry.
Oh man.
Yeah.
Start with
What
Russ.
is the let's go discrete manufacturing, specifically talking about discrete manufacturing.
Okay.
What is the most useful protocol, industrial protocol, for pushing data around in a plant environment?
So what's used the most, or what's the most efficient?
Efficient. This is what I want to hear.
Um, wow, that would be a loaded question. Meaning that if I was designing my own control, what I'm hearing you ask is, in a discrete manufacturing world, if I was designing my own control system, what protocol would I actually use at the underlying, let's call it level one of a Purdue model, level 01 of a Purdue model? I don't even know. See, now I don't get to open that box very often. I'm stuck choosing between the vendors and what they've already picked for me, and then trying to decide what I like or don't like about them.
I also
Hmm.
can't answer this question.
I
Yes, you
don't know.
can.
I don't know that I can answer this question, Terry. I mean, really, not without some thought. I mean, they all have advantages and disadvantages. Obviously, in North America, the most prevalent is going to be SIP, and when you get outside of North America, the most prevalent is going to be Profinet, and all the different variations of Profinet, RT, IRT, so forth. Um, the challenge is really trying to look at where are we going from a zero trust architecture perspective. What's it mean to actually start securing devices? Let's call it devices at the edge, so level zero devices. And the problem. So I'm going to pick my answer. You're not going to like it, but I'm going to pick a protocol that doesn't exist yet. Meaning that I would
Ah,
want to step back and actually write something novel and unique and new. I like the concepts that you get out of a lot of the produce consume model. So, I mean, whatever I did would be based on a produce consume model versus anything polling, just because of the efficiency gains. But I would also be looking to improve the security, both from an authentication and an encryption perspective. I like where SIP Secure has gone in leveraging being able to separate authentication to an endpoint versus total encryption and authentication to the endpoint. So I like that concept, but I don't know that I necessarily like the implementation for various reasons, in terms of the complexity and having to manage a PKI infrastructure and so on and so forth. So you're not going to like my answer probably, but my answer would be I would want to start with a blank piece of paper and kind of beg, borrow, and steal from the best of what I see in other protocols, and try to match or build something new, essentially.
there was too much intelligence in there for me to have a bone to pick with that statement, but it was on the verge of you were skating the question. All
I
right,
did.
Russ. You did. All right, Russ, hit me.
With the answer to that,
Yeah, what's you're the new guy, you're the CTO of a manufacturing plant. You've got free reign, you're building the plant.
yeah,
What protocol in parentheses S are you using?
me specifically.
You specifically.
Well, that's easy. I also will refuse to answer the question, and I will say, team of engineers, here are a set of requirements for what the system needs to do, and you need to go out and do not buy based on protocol selection. Buy based on a set of requirements for what it's going to do, and b a certain degree of interoperability that's required, and that will narrow down what protocols you can pick. I mean, there is no, you can't pick a protocol. That's like saying which protocol would you pick to run the internet. Dumbing this stuff all down to VHS or beta or DVD versus or Blu-ray versus HD DVD it doesn't apply in most of these scenarios yet, mostly because the protocols that we're talking about stack up on top of each other with multiple layers of abstraction, and the end package would be Blu-ray. But underneath Blu-ray, there's encoding, there's how it's etched onto the disc, there's what color the laser is that reads it, and that's like saying, what color laser would you specify on for next generation optical media?
So
It's just not enough. It's just not enough information to make that directive. And
so
this is coming from a place where my livelihood was tied to people saying, "You vendor must support protocol X," and I still would not specify protocol X.
so you both answered from the perspective of controlling the process or producing the thing. Get it. That's your first prior that's your first principle. I'm interested in if I want to execute large scale at scale data initiatives. So I'm thinking storage
Wow.
architecture, predictive maintenance, that sort of thing. which protocol lends itself best to that, or is it still
I'm
the
gonna
same
double
thing?
down. I gave the polite version of I don't know. Now I'm just gonna say directly I don't know.
But
If I'm landing asset data in a cloud somewhere or an on-premise server, do I care what protocol's been used?
oh yeah, absolutely, because you care about how much you can trust essentially what you're receiving, how secure it is, all the different things, or you ought to care anyway. I mean, whether you do or not may be another question. But I mean, I would love to fall back on the answer of building. I love Russ's solution, right? Give me a set of requirements and a team of engineers, and let's go build something. But I know that's not what you're looking for, so I'll yield or succumb to what you're asking for. And I think maybe we already hit on this in a prior session, but I mean, if I was going to take something available on the street essentially to solve a problem, I think there's two problems to solve in moving data to the cloud. One is, how do I do that on a continuous basis when I've got something that I'm very worried about from a time tag perspective? And then, and that would be OPC UA. And how do I do it when I'm looking for discrete packets of information essentially that describe an event in time? And my go-to there would be MQTT Sparkplug.
Russ, how
Well, I
about
mean, I would immediately start to argue about whether Sparkplug and OPC UA are implemented consistently across the board and whether you'd even be getting what you wanted. But besides that nitpick, I agree with his choices when feet held to fire.
so preface Larry's next visit? What do we want to pin him down on next time?
I think we just talk about OPC UA and Sparkplug. I'll
Okay.
actually be able to communicate intelligently about that.
We can do that.
Larry, when we set about doing this little thing it is we do here, we talked about learning publicly. That's why we want to do it, and it's why you're our favorite guest so far. Is there's so much to learn. Like, I will go back and listen to this because there's like a bunch of information that I didn't know. So I very much appreciate your perspective on these things.
Well, the only thing that worries me a little bit is coming across too authoritative, but okay. I know
No,
what's worked over the last 35 years. That's, I guess, where I'm oftentimes coming from. So,
yeah.
See you
Well,
next time, guys.
yeah, thanks, guys.
have a good trip, Larry. We'll look forward to seeing you soon.
All right, I
Bye, y'all.
appreciate it. Bye.